Hi, welcome to RAMESHSOFT video tutorials. In this video tutorial, we'll talk about singleton design pattern. So basically, what is a design pattern? So design pattern is a solution for a reoccurring problem, right? So what is a singleton design pattern? Let's feel that I'm having a class called test. So for this class test, how many objects we want? Those many objects we can create it. So I want to restrict the object creation for multiple times. That is, only one object I want to create a per class, even though when we are creating multiple objects, that should create only one object. That is, by using singleton design pattern, we can create only one object. That is, we can restrict the instantiation of a class and ensures that only one instance of the class exists. So we used many singleton design patterns in our regular Java. So in our Java runtime class is there, which is a singleton design pattern class, which is there in java.lang package, and desktop class is there, which is a singleton design pattern, which is there as a part of java.awt. Now see here, in how many ways we can implement the singleton design pattern. So we can implement the singleton design pattern basically in 5 ways. With the first approach is eager initialization, and second approach is lazy initialization, third approach is static block initialization, and the fourth approach is Threadsafe Singleton. Now let's see one by one we'll work on. Now the first one, eager initialization. So that name itself is telling eager initialization. Now see here, we can implement eager initialization that supports singleton, right? So to implement singleton with these all four approaches, we need to follow the rules. So this rules is applicable common to all these four approaches. What is the first rule? Number one is, the first rule is, should have constructor, that is private constructor, to restrict object instantiation of the class from other classes. That means whenever we declare a class inside a class, whenever we declare a constructor as a private, we can restrict object creation or instantiation of the class from other classes. The second rule is, class should have private static of a same class type, a variable. And third rule is, this class should contain a static method with a type to return the instance of the class. So the first rule is, to implement a singleton design pattern, three rules are basically, we have three rules. The first rule is, class should have private constructor to restrict object instantiation of the class from other classes. And second rule is, class should have a private static variable of same class type. Third rule is, class should have public static method with return type, the type as what? Class type. Now let's see here. So first one will implement with eager initialization. So we can implement singleton design pattern with eager initialization by creating object with static modifier. That is, in eager initialization, the instance of singleton class is created at the time of class loading. Static type is going to be executed at the time of a class loading. So now see here, let me implement singleton design pattern which supports eager initialization. Right click, new class, eager initialization. Yeah, now see here what I'm doing. So private static, so I'm taking type as a class type, some variable I'm taking is equal to new initialization. I'm creating object here, and second rule is take one constructor of type private. So here I'm writing syso of, or else not required, just I'm writing default constructor, and take one public static method that should return of same class type, right? So public static, and I'm writing get eager initialization. Now simple I'm returning eager. That's it. Now see here what I'm doing. Let me write the main method. Now try to create multiple objects. So eager initialization dot get initialization. Now I'm going to get the object. I'm giving some name as a even. In the same way, let me create multiple objects. Now change it to P2, 3, 4. Now say here, let me print hash code of this objects. Even dot hash code should have the same hash codes because all should point to same object. E2 dot, let's check our analysis is right or wrong. So implemented singleton design pattern or not. Plus E3 dot hash code plus E4 dot hash code. See here should point all objects means same reference, means should have only one object. Now see here we created 4 objects, but it should create only one object and all references point to same object. So all should have same hash code. Let me run it. Run as Java application. Now see here, so only one time constructor is executed first time, and see here same hash code is having or not. Yes, that is whenever we run this program at the time of class loading, this object is going to be created. So at the time of class loading, it is creating object, right? So that's why this is also called as a eager initialization. But see here, if you want, you can override toString method as well for meaningful string representations. So I'm overriding this method. So what I'm doing, just return eager dot, I'm writing hash code now. So directly now, if you want, just you can, instead of calling hash code method, simply you can call syso of, just you can call even syso of E2, syso of E3, syso of E4. Now let me run it, see the output. So we overridden the toString method of object class. That's it. So this is what about eager initialization. But the problem with eager initialization is instance is created even though we are not using the application. That is, this is there as a part of static, right? So whenever the class is loading, the static is going to be executed. But if you want to use this unnecessarily we are instantiating the object. That's why this is the drawback with the eager initialization, right? Now, second approach, second approach, static block initialization. Static block initialization. So, how to create a singleton that supports static block initialization? The same rules should have public static method that should have the same class type and should have a variable, and we need to have a private constructor to restrict the object creation from outside. Now see here what I'm doing. So let me implement second approach. So instead of writing here directly as a part of variable, this we need to write as a part of static block. So now just observe here what I'm doing. So this initialization is also called as a static block initialization. Static block test. Now just observe here what I'm doing. Same rules, common rules is applicable. All the same rules common for all the four approaches. Now it seems like similar like eager initialization, nothing great in that, right? Now see here, let me take one variable, private static, and here I'm taking one variable, and let me take static s is equal to new static variable, and then so here I took one static variable and then I took static block. Inside the static block I'm creating object for it, and let me have one method, public static method, public static get so I'm writing one method, return yes. Now see here, let me override that toString method, public string toString method. So here I'm writing return yes dot hash code method. Now let me override this method. Yes. Now let me take the main method, main method. Now let's call this object. Let's call this method to get the object dot get initialization. And now it's going to return the class type s1. So let me create another time. Now see here what is happening. So let me call syso of s1, syso of s2, syso of s3. Now if I run this program, these three objects is having the same hash code because those three is pointing to what? Same object. It means now see here, so we took one variable, private static variable, and initialization this we are performing as a part of static block, and we know that static blocks are going to be executed at the time of class loading, and we are taking one public static that returns of class type object. Now see here, when I run this program as a part of static block, that object is going to be created. That's why we are doing eager initialization, but this we are doing as a part of static block. So this initialization is also called as a static block initialization. So here also the problem is even though we are not using this application, that static blocks are going to be executed as the part of class loading. So we are instantiating the objects, right? Because this is there as the part of what? Static block. Now in this both eager initialization and static block initialization, we are creating object as the part of a class loading. So that is as a part of a static and that is static object creation, and we are creating or instantiating the object as a part of what? Static block. So the common problem in this is instance is created even though we are not using the application, right? Now one more approach is there. So how is there any predefined examples are there for this eager initialization means? Now see here some predefined, regularly we are going to use these things. Just to show me, let me show it. So runtime class is there. Runtime class. So runtime class is the best example for eager initialization. Now see here, so we have a class runtime and I'm having private static runtime sum is equal to new runtime. So here also we are creating object as a part of static. So at the time of class loading, this object is going to be created, and here we are having one public static method to get the instance of this runtime class, right? So this is one best example for eager initialization. Okay, so runtime is a class which is a predefined class which is there as a part of java.lang package. So third approach is now see here, third approach is lazy initialization. Now see here how to implement lazy initialization. Now see here, now let me create a class, new class, lazy initialization. Now see here I'm taking a private static variable of class type and let me write the private constructor to restrict the object creation outside of the class. So we know that whenever we declare a private constructor outside the class, we cannot create the object. And let me have a public static method that should return the instantiation of this class. Public static get now what I'm doing here, if s is equal to null, then return s is equal to new object and return yes. Now see here what I'm doing, let me take main method, and if you want you can override toString method. Public string toString method. Now return s dot hash code. Now if you want you can write @ override. Now see here what I'm doing. Now let me take the class dot call that method get initialization method. Now I'm going to get the object something L1. Now let me call 2 times. Now even though we are creating multiple objects, it is going to create only one object and all references points to the same object. Let me check whether all those are pointing to same object or not. L3. Now let me run this program. Now see here, so all objects are having the same hash code or not? Yes. It means whenever we are printing any object reference internally, toString method is going to be executed. That's why here I am overriding toString method for meaningful content. Now see here, so how the execution is happening. Now whenever we are calling get lazy initialization method, so it will come to this method. Now inside this method if s is equal to null, then we are telling create object, right? Initially this s is having null first time, so it is creating object and then returning this one. So second time whenever we are calling get initialization, it is coming here. Now the second time s is not null because s is already having the what object of type lazy initialization. Now it is false. Now it will come to regular statement and is returning what? Yes. S means what? Object, lazy initialization. That's why even though we are creating multiple number of times object, it is creating only one object. So this approach is called lazy initialization approach. So the problem with in this approach is it works fine in case of a single threaded environment, but when it comes to multi-threaded system, we get issues. If multiple threads are there, then it will destroy the singleton pattern, and both threads will get different instances of singleton class. So to avoid this, we need to provide thread safe, means at a time only one thread should access. That is, by using thread safe, we can implement a singleton. That is, by using thread safe, we can provide singleton. Now see here, so the fourth approach is singleton, thread safe singleton, thread safe singleton. Just declare that method as a public static method as a synchronized. Let me see here what I'm doing. So let me create one class, thread safe singleton. Now what I'm doing is, observe here, let me have one variable private something, I'm taking t. Now let me take one default constructor of type private. Now let me take a public static synchronized and the type as class type get singleton. Now write the logic for it. If t is equal to null, then create t is equal to new, now, and create the object and then return t. Now let me override toString method, public string toString method. So I'm writing return t dot hash code Now let me take main method and let's execute this program. Now see the result what happens. Now dot get threadsafe singleton. Now something t1. Now t2, t3. Now let me print the hash codes sys of t1. Even though if you print any object reference, internet toString method is going to be executed. So sys of t2. So even if you want, you can write t2 dot toString as well. Sys of t3. Now let me run this program. Right click, run as Java application. Now here we can provide a thread safety. We can provide thread safety for this singleton object. That is, only one thread is allowed to execute this method, so that we are providing thread safety using synchronized method, right? So what is synchronized and all those things, just watch my multi-threading videos, so there you can get what exactly this one. So here we saw total 4 approaches that supports some singleton design pattern. Okay, and thanks for watching the videos. Have a good day, boss.